to talk about logarithmic functions. All a logarithmic function is an exponential equation. So if you look at this last line here, log base b of y equals x, if and only if b raised to the x equals y. So basically, if we have a logarithm of base b, that's the base of the power. The y is the answer to the power, and whatever the log equals, which is x here, is the exponent. So if we try an example here, example A, log base 2 of 8 equals 3, and we want to rewrite that as an exponential equation, it would just be 2 to the third power equals 8. And that would be our exponential equation. So if we do log base 4 of 2 equals 1/2, that would be 4 raised to the 1/2 power equals 2. And the reason why 4 to the 1/2 power equals 2 is because a 1/2 as an exponent is the same thing as a square root, and the square root of 4 is 2. So that's all we have to do to rewrite it as an exponential equation. So next one, log base 1/2 of 16 equals -4. If we rewrite this as an exponential equation, it would be 1/2 raised to the -4 equals 16. That would be our exponential equation. The reason why this works is because the negative exponent actually makes the 1/2 become a reciprocal. So this is the same thing as 2 to the 4th equals 16. Same exact thing. And then the last one, log base 7 of 1 equals 0. We're saying 7 raised to the power of 0 equals 1, which makes sense because any number raised to the 0 power is always equal to 1 as long as the base is not 0. Just some special logarithms. One we just did, which we said the log of any base of 1 is always equal to 0. And then the other special case is when the log base b of b, so the same base as the answer, that means our exponent would have to be 1. So log base b of b equals 1. There's some special logarithms. Let's try to evaluate the expression here. So log base 4 of 64. We're just trying to evaluate that. We're saying 4 to what power equals 64. So even though it's an expression, I'm going to make it an equation so it'll help us out. Let's say that this log base 4 of 64 equals x. So basically, we're trying to figure out what x is. So 4 is the base, x is the exponent, and the answer to this exponential equation would be 64. So 4 to what power equals 64? Well, 4 to the third power. So you just have to figure out how many times do you need to multiply 4 to get 64. So 4 times 4 is 16. 16 times 4 is 64. So if you multiply 3 4s, that would give you 64. So the log base 4 of 64 would be 3. And that would be your answer. Same thing here. 2 to what power equals 32? 2 to the fifth power equals 32 because you need to multiply 2 5 times to get 32. So this answer would be 5. Same thing here. 5 to what power is 125? 5 times 5 is 25 times another 5 is 125. So it's 5 to the third power. So log base 5 of 125 is 3. So here we got 16 raised to what power equals 2? Well, now we're trying to figure out how we get a smaller number. So we can't really multiply 16 times itself multiple times, give you 2. So this time we really needed to divide it until we get 2, but we don't know what we're dividing by. So we're trying to figure out what is the exponent here. So what I'm going to do is actually not square root it, but fourth root it. Because the fourth root of 16 is 2, we know our exponent would have to be 1/4. Because 16 raised to the 1/4 power equals 2. So here's another one. We got 1/3 raised to what power equals 27? Well, we have a fraction here, so we really want to flip it so we can get 3 to the opposite of what power equals 27? So that would be 3 to the third is 27. So this would be -3. And then 4 to what power equals 0.25? Well, I'm going to change this 0.25 to a 1/4 because this will make more sense. So instead of 4 to the x equals 0.25, I'm going to say 4 to the x equals 1/4. So really all I need to do is the reciprocal of 4. And do the reciprocal, I just need to make the exponent -1. So those are a few evaluating the expressions. You're basically just trying to figure out whatever the base is, raise that to what power, and that'll give you the number next to the log, but not the base. Another common logarithm like log base 10 of x. So usually you don't see a log base 10, you just see the word log. Whenever you see the word log or the expression log, that just means you assume that there is a base 10, so we don't write it. This is going to be on your calculator. Same with a log base e. Instead of writing a log base e of x, we just say an L with an N. This is the natural log. So natural log is Ln, which just represents log base e. This is another one you can look at on your calculator if you're trying to evaluate these using a calculator. Examples, log of 7 or natural log of 4, you could just type these in your calculator. Log of 7, which is basically a log base 10 of 7, and natural log of 0.4 is the same thing as a log base e of 0.4. These are the same. But what we want to do is we would type that in our calculator to get a decimal answer. Let's try to simplify a few. So 10 log of 5. Now we just went over when you don't see a base, you assume that the base is 10. So what happens if we have a base of 10 and a log base 10? Well, these are basically the opposite of each other. So the 10 and the log base 10 will cancel out. So the answer to this expression is 5. Well, we got a 4 raised to the log base 4. So a 4 and a log base 4 will cancel out. So the answer to this one is 7. Then we got a log base 4 of 16 raised to the x. Well, log base 4 of 16. Well, I can write 16 as 4 squared. And then I want to raise that to the x. Well, here I could just distribute the exponents. So I got a log base 4 of 4 raised to the 2x. Now I have a log base 4 of 4, a log base 4 and a base of 4. Those are opposites, so they cancel each other out. So the answer to this expression is 2x. And the last one, log base 3 of 27 raised to the x. I can change 27 to 3 cubed because 3 cubed is 27. And then don't forget to put the exponent down on the 27, which was the x, right? 3 cubed is 27. 27 gets raised to the x power. So here I could just distribute the x. So I got log base 3 of 3 to the 3x. And now I have a log base 3 and a 3. They'll cancel out. They're opposite. And my answer is just what the exponent is, which is a 3x. And that is how I can simplify some expressions.